Imagine the mental weight of this impossible stack of textbooks. If you have ever sat through a marathon study session, staring at the same chapter for hours, you have likely experienced the frustration of closing the book only to realize you have retained nothing. In those moments, your brain functions like a computer with too many open browser tabs. The system simply locks up and stops processing new inputs. Why does 4 hours of high-effort reading often result in zero long-term memory? This friction stems from a physical bottleneck in the way the human brain accepts raw information. Every new fact you encounter must first pass through your active working memory. Think of active working memory as a temporary staging area where the brain holds and manipulates information before deciding whether to store it. This diagram illustrates a fundamental biological constraint. While the stream of incoming data is massive, the gateway to your memory is incredibly narrow. The human brain holds only 4 to 7 bits of information in active memory. Forcing more than 7 items at once causes system failure, and the brain discards the overflow to prevent cognitive shutdown. To bypass this limitation, we use the chunking method, a form of information architecture designed to group data into more efficient clusters. Since you cannot expand the physical capacity of the brain's gateway, you must instead change the shape of the information trying to enter it. Consider the structure of a traditional Kathiawati thali. It is an expansive platter featuring a dozen different components, from curries to sweets. You don't attempt to eat the entire meal in one go. You naturally break it down into manageable tukda, or pieces, consuming one bite at a time. This same logic applies to data. Take, for example, the challenge of memorizing a random 10-digit number. Presented as a single, unbroken block, these 10 digits exceed the brain's natural 7-slot limit, making them mentally overwhelming. If we fracture that block into 3 distinct clusters, we use spatial gaps to reorganize the sequence into meaningful groups. The total volume of information remains the same, but you have successfully tricked your brain into processing 3 manageable items instead of 10 separate ones. This principle scales up from a simple number to complex academic subjects, such as a 50-page biology chapter. To a student, a 50-page chapter often feels like a monolithic wall of text with no clear entry point. Instead of reading from page 1, you first scan the chapter to identify 5 core subthemes, or conceptual pillars. In this diagram, we see that monolithic chapter breaking apart and sorting into 5 distinct folders. By condensing 50 pages into 5 categorized themes, you align the material with your biological limit. You have transformed a massive, vague requirement into 5 discrete, solvable problems. Let's apply this to a specific list of 20 chemical elements that need to be memorized for an exam. Most students rely on passive rote learning, reading the list from top to bottom repeatedly. This is high-effort, low-reward work. The chunking solution involves analyzing the list and grouping the elements by shared scientific properties, such as noble gases or alkali metals. The scattered list rearranges itself into 4 neat logical groups. Creating a logical pattern allows your brain to anchor individual facts to a larger story, converting random noise into a structured mental map. For maximum efficiency, you can pair the chunking method with the Pomodoro timer, a system where you work in 25-minute blocks separated by 5-minute breaks. Under this system, you dedicate one 25-minute block to mastering only one specific chunk of information. This approach creates a double constraint. It limits the volume of data you are processing and the time you spend doing it, which helps prevent mental fatigue. Mastering the material one Tukda at a time prevents the cognitive blockages that lead to burnout. It provides a clear path to finishing the entire chapter without ever having to rely on mindless repetition.